So for this proof, we need to use the wedge out rule. And really what indicates this is the fact that we have one assumption that is a disjunction and there's nothing else that we can really do with it. So if we look at our wedge out rule, we have three different pieces for it. We have a wedge, which is one of our assumptions here. It's line 1. And then to do the wedge out rule, we need two separate arrows, one showing that one side of the wedge goes to our conclusion, and then another arrow showing that the other side of the wedge goes to the same conclusion. And once we get those three pieces, then we can assert the consequent of those two arrow statements. So in this proof, we're just going for T because that's our conclusion here. There are other cases in which the wedge out rule could be used to get to something before the final conclusion, but we'll hold off on that for now. Here, the conclusion is going to be what we put inside of our diamond. Now, if we are thinking about the pieces that we need, this is where the subproofs come into play. So here, we're going to have to prove this arrow statement. And so this will be the first subproof. So to build this arrow statement, we're going to need to assume the left-hand side and try to derive the right-hand side. And this will be like a self-contained proof. So if I were to give you the argument such that your conclusion was P arrow T, that's all you're doing for these lines here. You're treating your new conclusion as this P arrow T. And then once we get that, we'll move on to the next subproof that we need, which is the other arrow. So we need to get this other piece of our wedge out rule. And so we'll just do the same thing again to get this piece of that wedge out rule. And then once we get those two conditionals, we already have the wedge, so we'll be able to assert our conclusion here at the very end. So those are our three pieces. Here's the wedge, here's one conditional, and then here's the second conditional. And then once we get those three pieces, we can get our conclusion here. So if we're looking at this first arrow, this P arrow T, as I was mentioning before, if your conclusion was a conditional statement, the first thing you would do is assume the left-hand side as a PA, and then you would try to get to the right-hand side. So that's what we'll do here in line 4. And then the rest of it just runs like you're trying to do the arrow in rule. So you have a PA, and if we look at our second line here, if I had P wedge R, then I could get T. I don't have P wedge R yet, but I could build it by taking this P and wedging in this R here. And then now I have the left side of that arrow, so I can get the T by itself. And then once I get the T, I've shown that it depends upon my PA in 4, so I can build the arrow there in line 7. So now we've got our first conditional statement. We drop out that PA there. And you might ask, well, why can't we just stop once we get to this T here? And the reason is because we have the provisional assumptions still playing a role here in that derivation. So we can't have our proof end on a line in which one of our assumption numbers here in this part of the proof on this left-hand side, if one of those has a provisional assumption number in it, then we can't stop. We have to keep going until we get rid of those provisional assumptions. So we built the first arrow though here. Now we're just going to do the same exact thing for this arrow statement. We're going to assume the left-hand side, so we'll assume the Q, and then we'll look to try to derive the T. So got the Q, we can wedge in the S just like before, because if we wedge in the S, then we can get this T up here. So we'll wedge in S on the Q. And then once we get the left-hand side of that arrow up there, then we can do arrow out to get this T. So we'll just do Q wedge S to get T. That's what we get here. And then it's the same exact move as before. I assume the left-hand side of my arrow. I derive the right-hand side. It depends upon my PA here. So I can just build that arrow, and then I'll have to get rid of the PA number that's associated with it. So both of these subproofs are the same exact structure. That's sort of by design for this homework assignment. But hopefully you can see this whole subproof is just going for this derivation, and this subproof is just going for this derivation, and that's what makes them sort of self-contained. And once we get our three pieces, now we have our disjunction here, we have the arrow statement derived here, we have the other arrow statement derived here. So we can assert the T here in line 12, and we need to cite all three lines where our pieces are at. So line 1 is where our wedge statement's at, and then line 7 is where the first conditional is at, and then we need to cite line 11, which is where our second conditional is at. And once you get all three of those pieces, you can do wedge out. And as you can see with our conclusion here, we don't have any of the PA numbers in our justification, in our assumptions numbers, I should say. So that's how you do this problem.